Okay, good morning everyone. I Kaushik Dhola, convener of this STTP. I heartily welcome today's our expert, Dr. Varsha A. I also heartily welcome Dr. Nikunjar Patel, convener of this STTP. Before we start our session, let me introduce our expert. Dr. Varsha A. received her bachelor degree in electrical engineering from MS University, Baroda in 1986 and master degree in electrical engineering with specialization in power system from SVRCET in Surat 1990. She received her PhD degree in electrical engineering from SVNIT Surat in 2013. She has a vast teaching and research experience of over 33 years in the field of electrical engineering, working with SVNIT Surat, and also industrial experience of 1 year and 8 months at Surat Electricity Company. Her prominent areas of research are hybrid and electrical vehicle, energy sources and their management, electrical drives and power convert for electrical vehicle, battery charger for electrical vehicle, power system and many more. Under her profuse supervision, 3 PhD degree has been awarded and 6 PhD supervision are going on. She is also providing her expertise services in major industries based consultancy. She has given her proficient contribution in the project of Surat Municipal Corporation bus electrification assessment in coordination with National Renewable Energy Laboratory Department of Energy USA. She is a member of IEEE Vehicular Technology Society and many other societies. She has published around 26 research papers in national and international journals and 28 research papers in national and international conferences, including 2 book chapters. Today, she is going to deliver an expert talk on scope of research in electrical vehicle. Now, I would like to hand over this session Dr. Varsha Shah. Thank you, ma'am. Thank you, one of you.
Thank you for introducing me and giving a chance to deliver lecture on research in the field of electrical vehicle. Good morning to all of you.
Very good morning, ma'am.
Let us. Can I make the now full screen?
Yes, ma'am.
No? Okay. So once again, good morning to all of you. Today I will deliver my talk on research opportunities in the field of electrical vehicle. Of course, all of you are now aware of what is electrical vehicle and what is the reason behind that, behind the moving from one convenient or conventional transportation mode to another transportation mode, what we call it as electric vehicles, or many times we may interpret that as a green technology or green transportation technology. So let us start with some basic things and then I will discuss about where the scope is. So first thing is why e-mobility. All of you are very much aware that the first thing that is related with the moving towards e-mobility is India is one of the fast growing country economics in the world, but it always the economy of India will depends on its oil imports. That is the main can say the limitations. Then the rising environmental concerns, That means this conventional vehicles spoil the environment, and growing need for sustainable mobility solutions are posing serious economic and social challenges for the country. And electrical vehicle is the one of the solution, not the overall solution, but one of the solution to meet this requirement. So electrical vehicles are not just wave of the future, but they are saving lives today, because the tailpipe emission of this electrical vehicle is zero. So when it is operating on road, it doesn't generate any emission. So the environment effect while the vehicle is in operations will be zero. In the Indian electricity vehicle ecosystem market, analyzed by BIS research, the EV market is anticipated to grow at a robust CAGR of 43.13% during the forecast period from 2019 to 2030. And this is the scenario in India. But if you look at the other countries, they have already adopted this technology and they are using electrical vehicle. Additionally, installation of charging infrastructure is projected to grow at a CAGR of 42.38%. Because we cannot think about only as a transportation system as an electrical vehicle, because this electrical vehicle needs to get a charge, and that's why along with the electrical vehicle we must have to develop appropriate charging infrastructure. Then these are the limitations, or the can say, but what are the other factors which are propelling the e-mobility? And there are basic three factors as far as the electrical engineering part is concerned. That is advances in the renewable energy, that is one of the factor. Second factor is improvement in the battery performance uh, by different battery chemistry. And the third is advancement in power electronics along with the programmable devices. So these are the three driving factors or propelling factors for e-mobility all over our world. And as far as India is concerned, India proposes to add 175 gigawatt of renewable energy capacity by 2020, and to achieve 40% of its electricity generation from non-fossil sources by the same year. Of course, this was the target, but due to this COVID, probability is there that we may not achieve this goal. There is advancement in battery chemistry, and this have lead to a higher energy density, fast charging, reduce battery degradation from charging, and combined with the development of motors with a higher rating and reliability, this improvement in the battery chemistry have reduced cost and improved the performance of efficiency of electrical vehicle. So this is another driving factor. And the third is a power electronics, a critical factor propelling the shift from conventional vehicles to electric, hybrid, and fuel cell vehicle is the revolutionary improvement in the performance, size, cost of power electronic circuit over the past decade, with parallel improvements in sensors and microprocessors. So these are the driving factors for e-mobility. And what are the benefits that we are getting from EVs? Of course, other benefits, you are very much familiar with this, but here I would like to highlight a few points. One is the energy efficiency of a vehicle. The conventional vehicle will operate with 17 to 21%, or maximum you can say having an efficiency of 25%, while the electric vehicle will have the efficiency nearer to 90 to 95%. And that is because of this electric motor, because electric motor will always operate with higher efficiency and other components involved to design your electric vehicle. One more factor which again create a reliable operation of a vehicle in terms of electrical vehicle is having a very few number of moving parts. In electrical vehicle, almost 18 to 20 moving parts are there. While in case of IC engine, more than 2000 moving parts are there. So that is the reason why the IC engine will have low efficiency. But of course, we all know that this conventional vehicle will provide all luxury along with the minimum time for refueling. That is the one of the disadvantage or the limitations of electrical vehicle is a refueling time. Second is the cost of electrical vehicle in terms of volume. So we may have the cost only with the electric drivetrain. We are not considering the battery should be treated as a fuel. So we are not considering here battery cost. So the capital cost for IC engine driven and the electric drivetrain now almost reaching to the common point, almost having the same, can say the cost, capital cost. And as the demand increases, volume increases, the cost for electric drivetrain will further increase, and at the same time the IC will have the opposite effect. So these EV costs will be driven by R&D and Moore's law and the SW, and gap to widen year after year. That means as the time passes, the gap between IC driven powertrain and the electric drivetrains will further increases. Second is the fuel cost. The fuel cost we interpret in terms of, for a conventional vehicle, in terms of the petrol or the gasoline, and in terms for electrical vehicle, it is in terms of the battery cost, battery plus power cost, that is a charging cost per kilometer. So still we are not reached to this crossover point, but we may reach to this point because the petrol cost per kilometer definitely is very, very large compared to the cost per kilometer of battery. But the only thing is that the battery cost will be still larger. And if you are using it for a larger kilometers, then definitely the battery cost per kilometer will be lower than the petrol cost. R&D drives down battery cost continuously because continuous research and development is going on in the field of battery technology. And the third factor, as I have told you, that is related with the non-conventional source or the renewable sources, and the decrease in the cost of a battery. Previously, it was from $300 per kWh, and now it may approach to a cost nearer to $100 per kWh. So this is another, you can say, the EV cost in volume in terms of the battery cost will rapidly falling. And now the third thing is that as this battery needs to recharge. So question here is that, but do we have enough electricity in the India? Because we have a 200 millions vehicle likes to grow to 330 millions by 2030. So even if the thermal power was not available, if we will plan in a Rajasthan to have a solar power generation, then only 0.5% of solar panel of Rajasthan can generate all power required by 330 million vehicles. It means that we have an ample amount of natural resources in terms of the sunlight. So we may have, if we may go with a higher and higher renewable source use, then definitely this electricity requirement, the additional electricity requirement by vehicle can be matched. And pollution, EV, as I have told you, EV with the EV when operating only on road, having a zero emission. Of course, when it gets charged through the grid, then it contributes to the emission. But when we are charging it through renewable energy, then definitely it is a zero pollution vehicle. So you can say no tailpipe emissions, zero CO, HC, NOx, and PM, CO2 emission less than that for the petrol and diesel vehicles. So these are the few more factors which supports the use and the development of electrical vehicle. Now, to do research in the field of electrical vehicle, we first understand that what is electrical vehicle and what basically the field of electrical vehicle is a multidisciplinary field in which you need to have the knowledge of mechanical engineering, electrical engineering, electronics engineering, communication engineering, chemical engineering, and computer engineering. It is a multidisciplinary topic where and mainly three branches are more involved, that is mechanical, electrical, and electronics. As if what I think that the computer and the electronics is a sister branch of electrical engineering. So an electrical engineer can work in the communication area also, electronics area also, as well as computer area also. So basic requirement is you must have the knowledge of this interdisciplinary stream. Then only you can do a good level of research in the field of electrical vehicle. So in case of mechanical engineering, that means the manufacturing of vehicle, it is a process of mechanical part, right? Then the vehicle dynamics, to understand the vehicle dynamics, that what are the forces acting on the vehicle and when it is running on a road and how to manage that forces, how much power that you need, that is the part related with the electrical engineering and the chemical engineering. Then the thermal management of your system, then material science, because selection of your appropriate material and all that for building a vehicle, productions and manufacturings, and fluid dynamics. These are the important points which the researcher must have to do research in the field of electrical vehicle. And as an electrical engineer, you have the good knowledge of electrical motors, control systems, power electronics, and power system. All this multi group knowledge is required. And one more point, maybe as a electrical engineer, we are very much familiar with the functionality of electric motor. But usually our application has been limited, or you can say more with the industrial applications, where the profile of operating characteristic, where the operating characteristic profile of your drive is fixed. It's not dynamic in nature that anytime the operating characteristic of your drive will change when you are using that drive in the industry, having you can say a fixed profile. But when the same drive you are using electric motor, you are using for vehicle applications, the scenario will totally change, because the driving characteristic of your vehicle will ultimately determine the shaping of your electric motor characteristic. So here you should be more careful how to design your motor from the scratch and how to approach or how to reshape the electric motor characteristic to match with the vehicle characteristic. And the control system, power electronics, power systems, they are the interconnected part where you need to have the control of motors, you need to have the power electronics, and you have to control the power electronics also, so you need to have the knowledge of control system also. Another is electronics engineering, that is electronics control unit, embedded systems. You must have the knowledge of that, because your vehicle is, your electrical vehicle uh, has to, the functionality of the vehicle has to be controlled. And for the controlling the functionality of vehicles, you need to have the electronics control units along with the embedded system application. That means that can be, again, I can interpret like a use of microprocessor, microcontroller, DSP, or any other platform to program it. Communication engineering, that is a various communication protocols within the vehicle and outside vehicle, along with the charging infrastructures is required. Then chemical engineering, that is related with the energy storage devices such as batteries, supercapacitor, etc. We have the other types of, you can say, the energy storage device that can be interpreted as a magnetic system, as well as, you can say, a flywheel, and not as an energy storage device, but energy supplying device as a fuel cell. So again, the chemical engineering will involve in this. And computer science, cloud computing, data science, mobile applications, cyber security. Again, all this needs to be implemented with the electrical vehicle system along with its charging infrastructure. So to move towards can say research in the field of electrical vehicle, the first stage will always start from a mechanical design, electrical design, and then the control system design, then embedded hardware design, embedded software design. And for that, what you need is, the first thing is, you have to find out what is your system specifications, and based on that you have to focus on its mechanical and electrical designs. This is a core design part. Then how to control everything. For that you need to have the control system design, and then how we are implementing this control system part. And for that you need to have the embedded hardware design and embedded software design. And usually when we do or when we design a electrical vehicle, and then after when we go for a production, the first stage is like the system specifications, then the design part, and then after you have to do the complete simulation in a virtual mode only. And that's why what we call it is a VR. We are using a simulation environment to check the or test the performance of electrical vehicle under different operating conditions, as well as few more testing also we are implementing. And after this only we go for a physical prototype testing, and then the final is manufacturing test system design and evaluation has to be carried out. And then finally it went for to manufacturers and product support stage. So this way you need to move. So for to design an electrical vehicle or to work in the field of electrical vehicle, these are the special sections. You can select any of these sections and you can work on that. Because usually for a prototype design, before we go for physical prototype implementations, we always make a vehicle system design in a simulation environment, in which we have the various tools, MATLAB for mathematical modeling and controller design. Then we have the advanced vehicle simulator, which is available, which will allow you in a case where you don't have any mathematical equations to define your systems, you can use advisor, and you can test the performance of electrical vehicle under different environment conditions or different operating conditions, along with the different types of drive, along with the different types of energy storage device, even along with the engine and the electric drive, where the concept will be interpreted in terms of hybrid electric vehicle. Then we have the another software, NSYST, that is for physics-based analysis. Of course, this is a advanced level of software in which instead of doing only with the mathematical modeling, it considers the physics behind the system component, and they do the design, or they build the system component with the physics-based analysis. Autodesk Eagle Design Spark for PCB design, Keel or the Code Composer Studio for embedded software design, Opel RT Lab or a DSpace for hardware in loop testing. So we have multiple options, multiple, not only these, there are so many other, these are the few names which I have mentioned here that you can refer this. And those who are good in programming and all that, they can move in the special software design for electric vehicle, and the final manufacturing process, and with the safety testing, the main testing part that is related with the safety of your vehicle. So now if we look at the electrical vehicle and its infrastructures, we cannot and its infrastructure, this infrastructure is in terms of the basically a charging infrastructures along with the communication infrastructure. So we have an electrical vehicle, we have a charging infrastructures, and these two are uh, connected via communication system. So this is the basic electrical vehicle and its infrastructure. So in electrical vehicle, penetration in developing country requires the development of charging infrastructures and a reliable communication system. The infrastructure of charging stations may or may not include renewable energy system, but the trend has to be towards a renewable energy system. So if you look at this, this is the internal part of electrical vehicle, in which we have the first stage, that is, or I can start from here. We have the vehicle itself, which I have mentioned with the vehicle dynamic block. Then we have the motor, which provides motion to the vehicle. And we have DC to DC converter. Inside this motor drive, we have motor and inverter. We have DC to DC converter, and we have an energy storage device, maybe single or maybe a multiple energy source we may have. Then we have a multiple energy storage system. So you need to have the management unit, that if it is a single one, you don't require any management unit for this. But when it is an hybrid source, you need to have the individual management unit to select an appropriate storage device to deliver power to the vehicle. Then you need to control these DC to DC converters. So you need its own controller. Similar way for drive also, you need to have its own controller. And we have multiple devices, and we have to operate this device in synchronism with respect to each other, and that's why you need to have the master controller. So this master controller will provide a final can say command to operate the individual controller of the individual component of your vehicle. And finally, the motor drives will supply power to a transmission system and the wheel system. Here I have shown one block, that is a driving block. Here we have two possibility. Instead of driving block, let's say I can put a pedal also. For an actual electric vehicle, we have the pedal system, and through pedal we are giving acceleration and deceleration to drive a vehicle. And if we want to do the simulation of this model in a simulation environment, then the pedal will be defined in terms of the driving cycle. we may do analysis of this electrical vehicle either from designing the energy storage, and then we will finalize that what should be the vehicle power requirement. But usually we always move not in the front uh, or front model, but we always will have the backward model. In backward model, when we do our simulations, we provide input is a drive cycle. And what is drive cycle? Drive cycle is nothing but informations which we have related with the vehicle performance in terms of velocity variation with respect to time. And this vehicle dynamics, basically it will determine how much force that you need to drive your vehicle. So this and the force calculations depends on at what speed your vehicle is operating, what should be the mass of your vehicle, and what are the forces acting on the vehicle. So based on that, we are calculating, okay, this is the power needed by your vehicle, and accordingly we are controlling and we are designing or we do the sizing of motor, we do the sizing of this converter, and we do the sizing of energy storage device. Along with that, we do the control of all these components using the individual control units and master control unit to drive a vehicle. Of course, this is what I have mentioned is only with the electrical vehicle. But if we have a hybrid electrical vehicle, I think the Nikunj Patel sir has already explained you about hybrid electrical vehicle also, in which one more propelling device is there, and that is what we call it as an engine. I will just show you in the board. That you will have the engine unit, you have the motor unit, and that will be providing power to vehicle when it is a hybrid. Of course, to drive a motor, you have the source, and for engine, you will have the tank through which it is getting fuel and it's operate. So here, when you have these two propelling device, then definitely depending on the vehicle operation, vehicle mode of operation, you have to determine whether the engine will come in picture or motor will come in picture, or motor will deliver power or engine will deliver power. So this way, this two propelling device will make your system complex, more complex, because you have to take care of that. Say by using these two devices, ultimate our goal is to operate your vehicle in more efficient way. Our aim is to operate the system in more efficient way, and that's why we have to decide that at what time the engine will deliver power, at what time motor will deliver power. And this is the, you can say, one of the research area. And usually we call it as energy management and system of electric or hybrid electric vehicle. So wherever we have a multiple source, multiple driving units, in that case, your system becomes more and more complex, and you need to develop appropriate energy management system, which will take care of all the components to deliver power under different operating conditions in an efficient way. So this is related with the internal part of the electrical vehicle. Of course, you need to, this master controller will provide with certain communication part also, internal communications, and even it will provide facility to have the external communication at the time of charging. That I will show you in the next slide. And that is nothing but you have your own vehicle, then the electronics control unit, which will have the complete information about your vehicle data, and through internet and through cloud computing it has been passed on to the infrastructure, and with the application of vehicle user also. And these infrastructure part I have already shown in this part, that you have the EV source, charger, front end converter, and grid. So it means that I am interfacing electric power source, EV vehicle power source, with a grid through a front end converter and back end converter, which can be interpreted as a charger for this battery. And we may have a renewable source with a converter, and through energy storage system they can again contribute to to the charging of EV source, where maybe the grid may not be available, or grid may be available but having no sufficient power to charge your EV source. So with that, this what I have told you is the background for electrical vehicle. Now we can focus on the research field of electric vehicle. Basically, it has been divided into basic three parts, and that three parts will be interpreted in terms of sorry, in terms of the vehicle itself, which will have the more number of components: drive, power EC, power electronics compartment, and energy storage. So we need to do the control for all this. Then the second part, that is related with the charging of this EV. So we may have the different methodologies for charging: on board, off board. On board means it is available with the vehicle, charger is available with the vehicle, and off board, or you can say integrated charger. Integrated charger, it means that we internally we have the motor and motor will have its own winding, and motor is with the driver unit also, that is an inverter. So this whole assembly will be used as a charger. So you don't require an additional charger to do that. So that way you can have the vehicle component control, then the design and control of your charger with the different options, and with the different charge level, that is level 1, level 2, and level 3. Level 1 and level 2 is a slow charger. Level 1 and level 2, they are known as a slow charger, and with the power capability in terms of maximum you can go with 20 kilowatt. And level 3, this is level 1 is AC charging, and level 3 we may have the AC or DC, and today's we have the facility that you can go with 50 kW or even higher 200 kilowatt, even with AC and DC. So which level you want to prefer? Then again we have the charging methodology. Fast charging, this is the today's need. Slow charging, fast charging usually be preferred where the emergency is there or on highway drive. Whenever you are moving your vehicle on highway drive, then definitely you have less time to wait to refuel your battery, so that you can go with the fast charging. And slow charging, maybe I can say as a smart charging. May not be a smart charging or maybe a smart charging. And when we say about a smart charging, there is a tremendous scope to focus on this smart charging depending on the grid power availability and the vehicle power requirement with respect to their state of charge. So you will have a smart charging. You can focus on smart charging uh, as your research area, how smartly you can charge your vehicle without affecting the existing power system network. So, the inside this vehicle, we have a design of vehicle dynamics. As I have told you, it is related, more related with the mechanical system. So, mechanical engineer can do in a very better way. Then energy storage, single and hybrid, recyclable. Then we can focus in the research, because recyclability is the most important part, because nowadays we are talking about digital India and smart city. And the concept of smart city says that the city must have minimum emission and people can stay in the city with the good health condition. And that's why whatever component that we are using for electrical vehicle must be recyclable. So the external you can say the covering system and the internally whatever the can say the materials which we are using for designing an energy storage system must be recyclable. So if those who are interested in doing research in the recyclable part, they can focus on that. Then another area of research related with the single and hybrid energy source. Again, I will show you on this page that when we talk about storage, or you can say the source requirement for EV, we have to consider that what should be the characteristic of vehicle. The vehicle characteristic, usually the vehicle characteristic is always defined in terms of speed versus torque. So it is all, sorry, you should write speed over here and torque over here. So it is always desirable that this characteristic is like this. And if you will look at the drive characteristic, it should be like this. So to match with this requirement, definitely we have to shift this operating point from here to somewhat internally to match with the vehicle characteristic. That is one of the requirement. So you can focus on drive control, and we know that this is a constant T constant and this is a P constant period. And if you look at here with the characteristic of vehicle, it is always moving more in a constant power region. So we have to operate our drive in constant power region, and when we are operating our drive in constant power region, then definitely the power requirement will greatly reduce. And even the drive capacity to produce same amount of torque with this characteristic, and this characteristic will also reduces. And for your storage requirement, it again depends on the vehicle mode operation. Vehicle can operate in 3 different mode: basic difference mode, acceleration mode, then constant speed mode, or you can say the minimum acceleration mode, minimum acceleration, very small variation in speed, and the braking or deceleration. So depending on this, how much power that the vehicle is needed usually defined by this acceleration mode, because during this period your vehicle is moving from 0 speed to the highest speed or the rated speed. So in that case, the vehicle is always demanding very high power. So the energy storage device which we have to select, that must be able to supply this acceleration power. But we know that, and then after your vehicle is moving in the normal mode, so in normal mode, the energy requirement is hardly of 10% of the actual power demanded by vehicle during acceleration. So if I am having an energy source with the highest power requirement, and for maximum period of time I am only using 10% of that power, then definitely it is not, you can say, reliable, or you can say advantageous to select a single source with very high amount of power. And in that particular case, we may have a concept of hybrid power source. And we all know that when we have the battery will have the characteristic limitations that it has a high energy but low power. And when we talk about this acceleration mode, the power is very high because we need it for a small time duration, or you can say for a short period of time. So if you are taking high power from the battery, then definitely it will affect the battery life. So there is a tremendous research available in this field that how you will select your energy storage device for your vehicle applications with respect to their different mode of operations. Again, this braking mode, that usually we interpret as a regeneration. This is the one more advantage offered by electrical vehicle compared to the conventional vehicle, that there should not be any regeneration in the conventional vehicle. When your vehicle is already in momentum and when you are stopping it, lots of kinetic energy is there. But in case of conventional vehicle, that we are wasting as a heat. But in case of electrical vehicle, we can convert these energy into a electrical energy. So that regeneration will also play an important role. So as your vehicle is moving in the different modes, and then under that conditions the power requirement will be different, it is definitely advisable to go with the hybrid power source. And that's why there is a tremendous scope to have a design of hybrid power source, which is a combination of uh, two or more energy storage device to match with the vehicle requirement. So you can have the research in the field of energy storage with the hybridization of energy storage system. And it's really a very you can say a very active field in which you can focus. That's why here single and hybrid source, so you can have this. And then the device means, again, when we are selecting an energy storage device, I think in case of energy storage device, when we talk about battery, then we have the battery as a cell only. a single cell. So we have to make a battery module, right? So single cell has to be, that means a very good packaging, or you can say you have to build a battery model or battery module which consists of number of cells connected in series and parallel to match with voltage and current requirement of your power source. So when we are connecting these sources, multiple cells in series and parallel, then again we have questions that how many of them are connected in series or parallel, and how to optimize it. So this is, you can say, the another field in which designing a battery modules and optimize the sizing of these battery modules. You have to optimize the sizing of a battery modules. And when we have you can say, when we have the hybrid source, and usually for hybrid source, we have the two device. One we call it as a battery, and other one we call it as a supercapacitor. Anyway, I will discuss these things later on. So again, we will move to this. So these are the few things related with energy storage. Then the management system, as in the previous diagram, I have already shown you that you need to do the management in terms of the electronics, communication protocols, charge balance circuit. As I have told you that we have a multiple number of cells are there which we are connecting in series and parallel. So you need to have the management of that cell voltage and cell current. So charge balancing circuit is also required. Then how to balance that charge, for that you have to establish some optimization algorithm for charge estimation algorithm. That means what should be the charge of the individual cell of a battery, and once you will estimate this SOC, then you can now go for, you can say, that charge balancing can be implemented. And then the modeling of each and every component of your vehicle, that is a drive, or you can say the converter, inverter, motor, energy storage system. Even a vehicle model has to be modeled. Then our power electronics will play a very vital role. Without power electronics, we cannot visualize the complete, reliable, and efficient operation of electric vehicle. So the research can be focused at a device level, because now if you will look at the today's trend as far as the power electronics devices are concerned, we are moving from silicon technology to silicon carbide technology, and I have forgotten the name, but gallium nitride topology, right? So the different materials are used for device to improve its characteristic. So someone can focus on that also. Then the topology, what type of topology that you can prefer for your application, for inverter topology as well as converter topology, to have the efficient operation of your vehicle. Then the control of that converters and inverters, and their electromagnetic compatibility, EMI. This is the most important part, because in vehicle we are putting everything very nearer to each other, and every compartment is operating with the different frequency, and that's why the electromagnetic interference will be there, and that's why you have to check the electromagnetic compatibility. So lots of research going on in the field of EMI, how to minimize EMI effect of all these power electronics devices which are working with different frequency and which are put in the very small space. Then we'll have the motor. Motor maybe with the commutator or commutator less motor, but of course, if we'll have the commutator motor, then definitely it control is very easy, and you can have a wide speed control range also. But the limitation has been imposed by this commutator, so it is more better to have the commutator less machines, in which again we'll have a two category, with permanent magnet and without permanent magnet. So again, with permanent magnets, again we have some limitations, that it becomes a monopoly. Permanent magnet is monopoly of a few countries, and that's why, and it's very costly, available from the earth, rare earth material. So there again we have to do some compromise, and that's why non-permanent magnets are again the case. So you can analyze that, and you can do research in that way, or we can have a development of permanent magnets with the utilization of minimum rare earth material. And then we have to establish the control algorithm, then the braking mechanism for electric drive, either mechanical, electrical, and when we have electrical regeneration. So you can emphasize on the regeneration, how to increase regeneration in the electrical vehicle when it is operating with the low speed also. So these are the things related with this. And if you will have a multiple source, then you need to have the energy management system. So, and multiple source in terms of not only as an energy storage system, but as a multiple drive unit also, that is the engine and the motor. There also you need to have a proper energy management system and proper energy management algorithm to implement the the or to properly control the power flow from individual sources when your vehicle is operating under different mode of operation. So these are the scopes where you can focus your research. Then you will have the outside vehicle, then that is a smart grid with the renewable integration. Then you may have the IoT based system, and we may have the G2V. G2V is nothing but the grid to vehicle, and V2G is nothing but the vehicle to grid a system. There you can focus. A good amount of research work is carried out. You can focus on that, how to establish the power transfer in bidirectional mode from vehicle to grid and grid to vehicle, and with in an intelligent way or in a smart way. So you can focus on that research also. And this V2G will provide one more support to the grid in terms of voltage balancing, that is a support for a voltage, a reactive power as well as active power. So there is a tremendous scope to focus on the new avenue opened by this electrical vehicle with respect to their interfacing with the grid and to support the grid functionality. Then where to place a fast charging station. So placement of charging station or deciding, you can go with some optimization techniques to find out a place. Because that has to be, for that you need to have the certain informations related with what are the footfall of the vehicles that is passing through that particular area. So where the maximum vehicle footfall will be there, then definitely we have to find out the place for a charging station. And usually the fast charging station, this is usually preferred to have on a highway. And if you people are remembering, the government has given a good incentive to aggregator who are going to have their own charging station on highways. And government has put up that condition that there is charging stations between the two, between the area, or you can say the distance, within the distance of 25 kilometers on each side of highway, and they are providing good incentive for that also. So there is a tremendous scope in our charging strategy also, how fast you are charging your battery, or how you are charging your battery, which will not affect the battery life. This is the most important part related with the battery, or you can say this is a limitation of battery. And that is the reason why more focus is required for charging and discharging of battery, control charging and control discharging of battery. Then we have a vehicle to vehicle communication and V2Y, and usually these vehicle to vehicle communications will be available when they are in a parking lot. Sometimes your grid may not be able to provide power to charge your vehicle. Then let's say the one of the vehicle is fully charged and other vehicle needs power, and they would like to leave this place within a certain period of time. In that case, the vehicle to vehicle communication is also possible in terms of the power transfer, or vehicle to vehicle communications as far as your safety and the accident part. It will again help you if you have a good vehicle to vehicle communication. So tremendous research will be there, and there is a vehicle to home is also there, in which you can make your home power supply system much smarter for utilizing power from a grid and to charge your vehicle. And nowadays, people are mainly focusing on artificial intelligence, right? And system estimations, artificial intelligence with the autonomous vehicle applications. So we'll have the driver-driven vehicles and the autonomous vehicles. So of course, in India, the government has not allowed to do anything related to the autonomous vehicle. But in other countries, foreign countries, they are focusing on autonomous vehicle also. But in India, we don't have to think in this direction because we have a tremendous manpower to drive the vehicle. Of course, the main focus with the autonomous vehicle is to reduce the accidents, the fatal accidents on the road. So if you look at the vehicle, I have just shown you with all the different kinds of charger, which I have already told you. The charger level 1, level 2, which has been connected with this. Usually the level 1 and level 2 chargers are always available on board, that is in the vehicle. And if you'll have the level 3 AC or DC charger, then the same unit will be available outside. So the charging unit, if you look at the charging unit, will have AC to DC converter. That is, we usually call it as a front-end converter, maybe online, on board or off board. And then you will have the power factor correction unit, and then you have DC to DC converter. So this impose that you have a tremendous research scope while interfacing your vehicle source for charging with the grid, because this may generate some other uh, can say the adverse effect on the source side, and that one of that is in terms of their harmonics and power factor correction. So this is the whole vehicle. You will have the wheel. You may have the four-wheel drive. You may have sorry. You may have a four-wheel drive. You may have a front-wheel drive. You may have the rear-wheel drive, or you may have the drive which has been placed within this part, and then you will have the you can say the differentiator and the transmitting unit to transmit motion to the wheel, either of this. We may have the multiple electric motors for the same functionality depending on your requirement. We may have the different battery packs, one for the main propelling the vehicle, another for, you can say, the supplying the small power requirement demanded by the vehicle. and so on. So, as a short, I can say that the R&D required for EV subsystem is drivetrain, motor, and controllers, distributed motors. Reduce. Our main aim is that the reduce kW per kilometer power usages. So, if the motor demands less power uh, to drive your vehicle per kilometer, then definitely the battery sizing will also reduces. DC to DC converter and battery chargers and battery swapping system, electrically driven power steering, power brakes, and and air conditioning system. Battery packs. There is a tremendous research is going on how to do the packaging of your battery and battery cell, battery materials. Not only the packaging in terms of the soldering of cell, then putting the cell balancing circuit, and then managing the cell operations with the similar voltage level. Then the battery materials, lithium, manganese, cobalt, nickel, and graphite, and other new chemistry. Of course, now they have focused on some, you can say, organic organic materials. They're using organic material to build the energy storage system. Material for lightweight vehicles, material for better insulations to reduce heat and load. So you can focus on that also. Air conditioning process completes with drivetrain for a battery power. Better tires and better aerodynamic enhance which will enhance the energy efficiency of this. That means the shape and the tire shape, tire size, and the uh, can say the shape of your vehicle, because the better tires will reduce the rolling force required by your vehicle, and better uh, front design or better design of your vehicle body will reduce aerodynamic force. Vehicle controller software and integrations, and the future technology, that is a hydrogen fuel cell, battery chemistry handling with 45 degrees centigrade and grid integrations. So we'll see step by step. In case of energy storage systems, we have the chemistry point of view. We need to have the highly conductive components, increase the life of the device, increase the energy band gap between anode and cathode, research in solid state electrolyte and separators, then high thermal conductivity is needed, and high energy and power. I hope that you are familiar with the battery, so I'm just moving ahead of it. These are the different comparisons of various lithium-ion batteries. So you can select your battery according to the 5 parameters: safety, specific power, specific energy, cost, lifespan, and the performance. And amongst that, this LFP, lithium iron phosphate battery, is taking up more space for vehicle applications. Of course, people are focusing on lithium titanate chemistry also. But the limitations of batteries: poor efficiency, low power density, short life cycles, low operating range, and low current capability of batteries are the main limitations. And that's why we need to, as I have told you, that the vehicle is demanding two different level of power. For acceleration, very high power, and for normal operations, very low power. So in that case, if this power demand will get supplied by a device which will have the high energy density and high power density, but looking to the available energy storage system doesn't have both the characteristic together, and that's why we need to have a combination of two characteristic or two source which will match with the vehicle requirement. So in that case, we have the another storage device known as the supercapacitor. So supercapacitor is nothing but an electrical double layer capacitor, and is known as supercapacitor, ultracapacitors. Different names are there, and it has been First notice in 1957, and then after, and with the large volume, it is now available in the market from 1996, and in almost all field of applications, these supercapacitors are used. So this supercapacitor is an energy storage device that stored energy electrostatically by polarization and electrolytic solutions. Of course, it is like basically the similar to your electrolyte capacitor, but the difference is that it has a fast charge, fast discharge capability. The charging cycles and discharging cycles will be more without degradations. It has a very specific, high specific power density, or power density will be very high, and energy density, but the energy density is low, having low series equivalent resistance, etc., but having some disadvantage, uh, that is related with the high frequency circuit applications or with the AC voltage, and the voltage level of each cell of supercapacitor or ultracapacitor is less, that is 2.7 volt. So that will again, just like a battery, you have to put up all these cells in series and parallel to achieve a required current and voltage level. So engineering point of view, when we go with the hybrid power source, then how to control that hybrid power source, and what type of converter topology that we can prefer, so that we can have the control of battery, control of supercapacitor, and with respect to the different power requirement of vehicle. Then you have development of proper management algorithm for this device, because we have multiple source, so we have to select appropriate source through the proper management algorithm, and people are focusing, the good research is going on in the field of power, you can say energy management algorithms. Different energy management algorithms are there, and you can select appropriate algorithm, maybe that can be divided in two part. One is a heuristic algorithms, or you can say a rule-based algorithms, in which you have normal rules, or you may have the fuzzy logic-based rule systems, or you will have, you can say, optimized-based algorithm, in which you can even use your AI or a neural network applications or a dynamic programming. Different algorithms are there. You can use it to manage the power flow between the two devices. Integration of charge balancing circuit as the inverters to control the motors. Improve the insulations and reduce the losses in the connecting system. That is again a very important area. Improve the thermal management system with both air and liquid coolant system, and developed a strong encasing in case of multi-functions and gas leakage, as it is dangerous. So you can have the thermal management and battery encasing. So you will have the proper cooling system, external cooling systems and internal cooling system, and appropriately you can have the thermal management of battery. There is a tremendous scope in the battery management system also. One of the field that accurate charge estimation technique with less computational time, that is the charge estimation technique, usually we call it as the SOC measurement, and there are many more number of, you can say, the techniques are available, and usually it is very important to determine the initial charge of a storage device. Usually we are not in position to measure that with the normal Coulombic method. So there are different, you can say, the Kalman filter methods, or different methods are there which you can use to estimate the charge, initial charge also. Then the battery modeling, as when say initially we always do the simulation, so you need to have the proper modeling of battery, or proper modeling of battery and supercapacitor. Development and deployment of the active charge balancing circuit, that is another area. And this is what I have shown you with the battery management system, which involves so cell level management to with respect to the temperature And with respect to your input voltage, which I will show you in the next slide, that what you need to have the SOC algorithm, SOC limit, then the temperature limit, and based on that, fault limiting and lifetime predicting. After that only you can get the battery power output capacity. So this is our battery management system algorithm framework, in which even you can have the cell fault also, overall fault also, then the overload conditions, SOC to be high or low, because we have to charge each and every cell with the same level. Then the charge estimation algorithms are the different SOC methods are available. Conventional, in which either you can only measure the open circuit voltage and then you prefer the you can say data provided by manufacturer, and then you can find the SOC, or you can go with the Coulomb method by integration of charge. Then you have the adaptive filter algorithm, in which usually we prefer to have the Kalman filters and other H filters, UPF, PF. Then the learning algorithm, that is ANN method, that is artificial intelligence method you can use. And non-linear observer methods are also available, and other methods are there. You can prefer that method. Then you can focus on how to balance each cell balancing circuit, which is basically a part of your energy management, the battery management system, active and inactive. So this is like a passive balancing circuit which you have, and in the next slide it is an active balancing circuit, because you are using a controller to control it. In the previous case we don't have that controller. So there are different field in which you can focus your uh, then it is very much required that you must be able to diagnose the fault in the overall system of your vehicle, for even for a battery, supercapacitor, converter, inverter. Different methodologies or fault diagnosis methods are there. You can prefer any of these method, and you can do the fault diagnosis also, because this fault diagnosis is very important to have a reliable operation of your vehicle. There is a tremendous research scope in the power electronic system, the development of high frequency converters to reduce size and converter, because we know that when the system is operated with high frequency, the component size will reduce. Then development of cheap techniques for improving electromagnetic compatibility. This is the most important part. Development of control algorithms for a wide range of operating converters, development of embedded systems and sensors to be compatible and cost effective with high frequency converters with complex control algorithm. As we introduce a power electronic system, the system complexity increases, and that's why it requires more careful design and control of the system. For DC to DC converter, we'll have the different types of DC to DC converter. You can focus on that: linear mode operations, hard switching mode operation, and soft switching mode operations. So depending on your applications and your requirement, either you can select a linear mode operations or a hard switching or a soft switching mode operations. So in linear mode, usually we go with a series or parallel regulators, and on hard switching mode, either we may have the non-isolated or isolated topology. And this in case of non-isolated or isolated topology, we'll have the different configurations or different names of DC to DC converter, buck boost. And here we need to have the bidirectional converters, DC to DC converter, because we would like to have the power flow from grid to vehicle and vehicle to grid. So we'll have the multiple configuration. And to just for an example, I'm just showing you to have to control the DC to DC converter. Then you will have the you can say your input voltage with the disturbances we are providing, and there is switching signal techniques: PID controller, hysteresis control, adaptive control, current program control, variable structure control, and a sliding mode control. And you can have the control of the converter. So different methods are there, different topologies. Even for a converter also different topologies are there. I think machine drives, the sir has Nikunj sir has already explained you about the same. So either your research in the field of electrical machine may be at the design stage or at the control stage. You can have, but the most important part is to operate this vehicle in regenerative mode, this motor in regenerative mode, that is as a generator. And there are different control techniques for motor drive, scalar control, vector controls, in which again you have the voltage control, current control, FOC, DTC, and then SVPWM, SVM, hysteresis, either with the current control or the voltage control. So you will have the different methodology. And if you want to design it, then these are the design considerations which are provided by the NC software, in which you can consider the fluid dynamics part also for a motor. Uh, then you can have the interconnections with the Simulink, MathCAD, and Model Sim. Then parasitic effect also we are considering while modeling the motor. Thermal stress, BMD, and electromagnetic effect also we are considering, as we have this magnetic expert also. So you can select appropriate material, you can provide a electromagnetic interference effect or a nullification of this. That means we are modeling the motor in such a way that it act like a real system. The tremendous scope for the device selections and selection of device material. Silicon carbide, gallium nitride, and silicon power transistor switches for electrical vehicles. Usually, still currently we are using silicon power transistors. Uh, and the 20% losses is occurring because of the transistor switches which we are silicon based power transistor switches which we are using in a vehicle. The losses in switches during conduction and switching can be overcome by proper selection of switching material. So silicon material that currently used in the electric vehicle applications has limitations due to its physical property and energy gap. So if you will have the comparison between silicon carbide, silicon, and gallium nitride, uh, the silicon carbide is more preferable because it has a good thermal conductivity, as well as the melting point is again good. But only thing is that the electric field will be less. So not more preferable for high voltage applications. But high frequency switching is more preferable even for silicon carbide and silicon gallium. Sorry, gallium nitride. So if we'll check the band gap, electromobility, peak electron velocity, critical electric field, thermal conductivity, and dielectric constants, then you can find that the gallium nitride is more superior than even silicon carbide. But silicon carbide is superior than silicon device. And the most important part for a device selection is related with the reverse recovery characteristic. In case of silicon based device, the reverse recovery characteristic you can see it is a very adverse characteristic. But if you will see with the silicon carbide, it has a very good response. So it is much better to select a appropriate device material so that a better performance of vehicle is possible. Then we have the research in the charger technology also, different types of charger with the charging strategy. This is the most important part, that you have to select an appropriate charging strategy to charge your battery. So there is a scope to have development of charging strategies such as CCGP, MCC, that is a multiple current level charging, CCCV, that is constant current, constant voltage, and pulse charging, sinusoidal ripple current charging, to avoid degradation of battery. And there is a development of integrated charging system where the induction motor is used as a filter and the inverter is utilized as a and the boost converter operates in the buck mode to charge the device. So you can have the multiple research scope to do research even in the field of charger technology, designing a charger, controlling the charger, etc. Then the research scope in the various form of the vehicles and infrastructures. As that I have already told you, the development of vehicle to grid service and various algorithm for decision making. This is generally based on the Internet of Things and cloud computing with big data analytics. So you can have the tremendous scope in this infrastructure with infrastructure interaction. One more point which I would like to point out, that you can utilize a battery which are not used now. After using the battery in vehicle, now it is not used in the vehicle, that can be used for power system application, that is a grid applications. Then we have the concept of smart grid and EV. Definitely this smart grid concept will provide good communication between the that means you can develop a good software to have the proper communications between the vehicle aggregators and the grid. And then depending on the grid power level conditions and the power requirement of battery, you can have the smart grid applications. And in smart grid applications, the grid itself will decide when to charge vehicle and when to disconnect that vehicle, so that the grid impact can be greatly reduced. So this is like a load flow analysis for this, that how much power that the EV is defining, that has been given to the primary controller, then that governor and the turbine, and then it supply power to the grid. Then these are the power requirement from the smart home and the other loads that has to be supplied by the smart grid. Then we are inputting up power from the PV array and the wind turbine. So the turbine, or you can say the conventional power and the non-conventional powers, are available at the smart grid. And then we have the EV aggregators with the different, you can say, the charging stations, aggregator 1, 2, 3, and aggregator, and they are connected with the smart grid. And the smart grid will take care of when to connect it, when to disconnect it, how to communicate it, and how to provide that information to the aggregator or to the individual vehicle uh, owner, that the vehicle can charge with this, and what are the rates, and how to monitor uh, the charge to be accepted by the grid from a vehicle, or the charge to be accepted by vehicle from a charge. So you need to have the smart metering techniques also. So there is a tremendous scope in the field of integration of vehicles with the power system, and the impact minimization. Then Internet of Things, the IoT based system for electrical vehicles are the present trends in as it enables the autonomous vehicle. So this will provide autonomous operation of vehicle. And so IoT is a sensor system connected to electronics control unit with Wi-Fi capability that can be connected to the internet, and data is then stored by the server. It means that in other way we can say that you will have the GPS navigation, radar system, LiDAR, video cameras, other radars, position sensors, ultrasonic sensors, and inside these you will have the central computers will monitor your car through IoT. That means you will have a connection with the vehicle owner, to the grid, to the supplier, vehicle supplier, and the charging point. And this cloud-based system provides a two-way communications between consumers, infrastructures, manufacturers, and dealers. Means you can have the communications with all supplier also, consumer also, infrastructure, that is a power system part, and the dealers. There is a problem with the cyber security, so there is a scope of research in which you can go with you can develop cyber security applications for EV. There is one way this vehicle to infrastructure communications, like not autonomous of the vehicle, but here you have the facility that many times the driver will always facing, can say he's not very happy to park vehicle, right? So in that particular case, this vehicle to infrastructure communications with the developed app will provide a facility, yeah, to the driver that just move to the parking lot, put your vehicle at one appropriate place, and then apply your vehicle to infrastructure communication app, and through that app, the autonomously your vehicle will move to an appropriate parking place. And even it will, this software will take care of, it will guide the uh, vehicle to move in the parking lot, including the ability to help avoid pedestrian and the other hazards. And if infrastructure sends something in the vehicle path, it can stop and vehicle uh, immediately, stop the vehicle immediately. And driver will also use the app to request the region of the vehicle to the designated pickup area, expediting the parking experience and removing the responsibility of finding the vehicle upon return to the garage. So that type of applications, the research, uh, you can do research in that. Then you can go with the intelligent or a smart parking system also. Like my vehicle is moving on a road and now I'm searching for a charging station. So if we have the appropriate app, and that app will be connected with your intelligent or smart parking system, then it will provide all the information that which nearby parking place is available, where whether the parking place is available, space is there or not, then what type of battery that you would like to charge, so that slot is or that port is available for the charging. Then the charging strategy also, you can inform that okay, my battery will get charged through this charging strategy, then they will provide option for that also. So that way you can make your intelligent smart parking system. Then other research scope is choosing an optimal placement of fast charging station, which I already told you. Deployment of supercapacitor based buses for short distance travel. I have seen one bus, one the city bus in Beijing, where that is operated only with the supercapacitor. Developing a tariff scheme such that it includes battery degradation, consumer profile, and utility benefits. So, because this tariff scheme is again very important part as far as the consumer interactions with the grid is concerned. Development of an accurate vehicle dynamic suspension systems and transmission system, and analysis on impact of EV on various aspects of life such as economics, job opportunities, technological developments, consumer perspectives, and industry's perspectives. So these are the scopes where you can do research. So in short, there is a short-term R&D and the long-term R&D, and I'm concluding with that the short-term R&D would be required for electric motors and controller, DC to DC converter, EV chargers, electric power steering, electric power brake, electric air conditions, vehicle control and management, and communication protocols. Another area that will require R&D is to understand the impact of large-scale charging on electric grid and how to minimize that impact. There is a tremendous scope to do research in that. Even for that, you can use IEEE standard bus systems, and you can determine which bus is more capable of providing integration or connections with the vehicle, electric vehicle. Some key actions to prepare for greater EV penetrations are demand side management. That is another thing that is related to the availability of power, dynamic electricity pricing, and vehicle to grid technology for use of EV as active load and generators for power demand shaping. It means that it may act like a load or it may act like a generator. And beside that, we may have the long-term R&D also, and this includes the hydrogen fuel cell, new battery chemistry, that is with a higher specific energy and higher energy density, battery materials, and chemical distributed chemicals, distributed motors, batteries withstanding higher temperatures, motor without permanent magnets, heavy trucks, and two-way power transfer between grid and EV chargers. So I am concluding here that we have to put more focus on R&D and startup and make in India, which helps preserves India's GDP and grow jobs. So now the future really in our hand.
Okay, thank you so much, ma'am.
So thank you so
And
much for listening to me.
okay, and some questions from the participants,
Okay.
and that is in our screen.
I'm not getting this
UG
thing.
students, questions from the UG students right now
Okay.
in on screen.
Just wait, I'm not getting a screen. That's why.
Okay, fine.
End of slideshow. Okay. Let me have to minimize this.
Yes, ma'am.
Okay. Right. So where the question is?
On screen, ma'am.
On
Triparty
screen.
Ayush. Yes, Triparty Ayush. Is it visible on screen, ma'am?
Where it is available, I don't know.
Yes, ma'am. Screen. It is visible, ma'am. Screen पे ही है आप देखो.
Map. Okay,
Trip-
okay. Okay. This is right. Can we charge our lithium ion battery from solar panel with the help of controller by simply mounting it on the rooftop of four-wheeler, which will not cause any kind of disturbances in. Actually, say you can charge your lithium ion battery from solar panel, uh, but as you said that it is on the rooftop of the four-wheeler, then here the question is that whether that solar panel is will provide sufficient power to charge your vehicle. If it is a small vehicle, you can charge it. And in that particular case, you because the solar power will be the DC one, you can directly do that without causing any kind of disturbances in the grid power, because your solar panel is available on the rooftop of your vehicle. But you can have the concept of a solar powered charging station, and there you may have the can say as a part of, you can say, distributed generations. I can have the isolated this grid, isolated from a grid, so that you can directly connect your vehicle with the solar panel. But we have certain limitations with the solar panel, that the power availability is for a certain period of time only. So in the night, if you want to charge it, then you have to provide appropriate storage device, available storage device, which will help you to charge your vehicle, or otherwise you have an integration with the grid.
Okay, ma'am. One more questions from the participants. Yes, ma'am. Is on
Is
screen.
there any industry or institution which is working on fuel cell technology? Actually, I'm not sure about it, but so many institutions are there where the people are focusing on fuel cell technology. They are doing research in the field of fuel cell technology, and I think in Pune some industries there, they are focusing on development of fuel cell.
Yes, ma'am. Okay, ma'am. No more questions, ma'am.
Okay, thank you so much.
And yes, Nikun sir. Mic, Nikun sir, mic is not on. Nikun sir, yes.
My,
Yes.
thank you very much, madam. Behalf of Sri SWAMI ATMANAND Saraswati Institute of Technology, and I am Nikunj Patel, really thankful to you for accept our invitations and spend your valuable time with us and give us such a wonderful knowledge about the electrical vehicle. Madam has already covered the every aspects of research in electrical vehicles. We also know that the many developed countries have already adopted the EV in place of the IC engines. But if we focusing in our India, then the India is now started in this way. And as per the current declaration by the Union Transportation Minister Nitin Gadkari sir has announced that in nearest futures before 2030, the 69,000 petrol stations may be converted as a electrical facility. So I hope this topic and this area is give with a new scope of research. So once again, ma'am, thank you very much for spending your valuable time with us, and I hope so such kind of knowledge sharing is maybe continue in future. Thank you very much.
Thank you,
Thank you so
ma'am.
much, and thank you to all participants uh, for listening me very patiently. Okay.
Thank you, ma'am.